you've all gathered here for a case study discussion on design of a common emitter amplifier in FM receiver application. So we know that in a FM receiver, it receives RF signal. Okay? So we have to design a common emitter amplifier such that it operates at 100 megahertz and its gain should be approximately 10 dB. So this common emitter amplifier can act as a pre-amplifier stage in FM receiver, that is before mixer, or you can call it demodulation stage. Before that, this common emitter amplifier can act as a pre-amplifier. Okay, so we have to design that in such a way that especially at high frequency there occurs impedance matching problem and parasitic capacitance problem. We have to design a common emitter amplifier such that it can overcome these two problems. We know that impedance matching means the signal impedance at the source should match the signal's impedance at the drain. Else what will happen? The signal will reflect back to the source. So you have to overcome this while designing the amplifier. So I'll give you 5 to 10 minutes. You can discuss among yourself and give me a better solution. So hope you have completed your discussion. You can give your solution.
Basic requirements of this are FM band. It should be 100 megahertz frequency, and then the voltage gain. So it should be approximately 10 dB. And then input and output impedance. It should be 50 ohms. And then load mixer input also should be in the 50 ohms. And then the stability factor. They need to be the constant value should be greater than 1.
So I'm going to say about the design requirements. We are going to use the BF199 or 2N51 IC, which should have a Fourier transform of lesser than 300 megahertz, and we are going to use the C configuration with inductive degeneration for linearity and stability. So the collector emitter voltage should be 4.5 volts. Our target collector current should be approximately 5 milliamps. So here and above, coming to the resistors, we are going to take for the collector resistance, we are going to take 2.5 ohms, and for the emitter one, we are going to take 0.5 ohms. So in the base, the voltage should be 1.2 volts, and the remaining R1 and R2 resistors each should be of around approximately 30 ohms.
So I'm going to share about the design considerations involved. So first of all, we are using a bypass capacitor for around 100 nanofarad, and next is emitter degenerative inductor, and it is used for input and output coupling, and it took place in the LC tank circuit. So what are the operations involved means, in this circuit we are giving an around 50 ohm load, as well as the circuit involves series inductor as well as shunt capacitor. So how the working takes place means, it takes the reverse of input and gives the output.
So, okay, let me conclude it. So in here we are using common emitter transistor. So why we are using common emitter? Because it gives high gain. So with the help of common emitter amplifier, so we are processing a pre-amplifier with the RF value. So why we are using it? Because it's given a center frequency about 100 megahertz. We are using to consider like BF199 or 2N5179. So with it we get a gain of around 10 dB. So the condition must be satisfied with the stability must be greater than K greater than 1. Stability must be greater than 1. So with it we get a constant 50 ohm matching for the both input and outputs. So by applying it in the class A amplifier, so we get the output. So the after simulation, so we get up around 9.8 dB and minus 15 dB at the input return loss. So in conclusion, the common emitter amplifier acts as a
Yeah.
pre-amplifier in FM.
So thus, as per the discussion we had, we can design a common emitter amplifier by considering the stability factors and the proper impedance matching with the help of LC network. We can make use of this common emitter amplifier as a pre-amplifier in FM receiver gate. And we can also employ class A amplifier as a part we discussed. Thank you all.